Before you can evaluate whether or not your food has been produced in an environmentally sustainable way, you need to know what environmental sustainability actually is. Most likely, you've heard of environmental sustainability, probably on the internet, TV, or in newspapers, raising questions like, do cows really result in more greenhouse gas emissions than our transport system? Can we produce food without an environmental impact? The impact of food production on our Earth is a hot media topic. The term environmental sustainability, however, is used in many different ways, often with different meanings which can be confusing. This video therefore explains what environmental sustainability is, specifically in the context of food production. To be environmentally sustainable, we first should ensure that our natural resources remain completely and indefinitely available. This implies we should not exceed the regenerative capacity of a system. You can compare this with a bucket of water. The bucket represents the system, and the water level the stock of natural resources such as land, fossil energy, fossil phosphorus, and water. The bucket has two taps. On the top left side, water enters the bucket. On the bottom right side, water leaves the bucket. To maintain the same water level, the speed or rate of water inflow should be equal to the speed of water outflow. In other words, the in and outflow of natural resources through the system should be equal in order to be sustainable. We should balance the in and outflow taps at an equal speed. Now let's look at an example when in and outflows are not in balance, the case of fossil energy. When we talk about fossil energy, we refer to resources such as coal, oil, and gas. Dead organic plant and animal material have been transformed into, for example, crude oil. The rate at which these resources have been produced is very low. It took millions of years, whereas we are currently consuming these resources at a very high rate. Consequently, the stock of fossil fuels quickly reduces. As you can see, the top left tap has a very small water inflow, whereas the bottom right tap has a large outflow. Hence, the water level in the bucket, representing the stock of fossil energy, quickly reduces and is unsustainable. So we need other, more sustainable ways to use energy, such as solar, geothermal, wind, and bioenergy. Besides maintaining the regenerative capacity, you also need to look at emissions to air, water, and soil. The main greenhouse gases related to food production are carbon dioxide, methane, and nitrous oxide. But how many emissions do we find to be acceptable? To be environmentally sustainable, we should not exceed the absorptive capacity of a system. You can compare this with a sponge and its capacity to absorb water. The sponge represents the system, and water represents the emissions. A sponge can only absorb a limited amount of water. In practical terms, this means that a system can absorb only a certain amount of emissions, but at a specific point the maximum will be reached. Exceeding the absorptive capacity of the system is unsustainable. Let's look at the example of phosphorus and livestock production. One environmental issue related to phosphorus and livestock production is leaching of phosphate to ground and surface water. Most soils have a substantial capacity to bind phosphate. At a certain point, however, the soil becomes saturated and the absorptive capacity of the soil has been reached. At that point, phosphorus can start leaching into the groundwater. So what is the absorptive capacity of the soil in terms of phosphorus? This is not as easy as it may sound. In most cases, there is insufficient knowledge to accurately estimate the absorptive capacity of a system. To be environmentally sustainable, therefore, a food system has to operate within regulation standards. Unfortunately, so far no such regulation exists regarding, for example, greenhouse gas emissions and food production. We, therefore, can only compare emissions of various food systems, but we are unsure which reduction level is exactly needed to be environmentally sustainable. You've now learned that environmental sustainability consists of two components, regenerative capacity and the absorptive capacity. So, environmental sustainability implies that natural resources are used in economies or societies at a rate not exceeding their regenerative and absorptive capacity. To conclude, you might wonder what happens when the regenerative capacity or absorptive capacity of a system is exceeded. Well, exceeding these puts pressure on the environment and can lead to severe environmental problems or issues such as acidification, eutrophication, climate change, smog, ecotoxicity, soil erosion, and deforestation.